6.5, interpreting the behavior of accumulation functions. So if a is constant and big F of x is equal to the integral from a to x of f of t dt, then remember from last section, the derivative of f of x, so f prime of x, is equal to little f of x, because the integral and the derivative and the antiderivative kind of cancel each other out. Okay, this is often going to be a given information in some kind of problem you're going to get. And then they're going to ask you to interpret the behavior of big F of x. Okay, so if I want to know if big F of x is increasing, what do we normally look at? We normally just see if big F prime of x is positive. Since big F prime of x is equal to little f of x, then I'm going to look at the given information and see when little f of x is equal to greater than 0. So if I have this statement here, I can either write big f prime of x is greater than 0, or I can write little f of x is greater than 0, and they're equivalent, and it just depends on the given information that they provide for me. So if I want to know if f of x has a relative minimum, I want to see when f prime of x changes from negative to positive. Since f prime of x is the same as little f of x, it's possible that I will look for when little f of x changes from negative to positive. And this is because they often will give you the given information of little f of x, so that's what you're going to have to interpret. Okay, if I want to know if f of x is concave up, I'm looking at the second derivative. So I want to know if the second derivative is positive, because the first derivative of big F of x is little f of x, and the second derivative of big F of x is f prime of little x. So I can look for either of these statements to be true to prove that this is concave up. And if I want to show that there is a point of inflection, that's concavity. So I want to see when big F double prime changes signs, or I can see when little f prime changes signs. And based on the given information, I often use little f prime. Okay, so let's see an example where this will apply. So for example 1, let g of x equal the integral from a to x of f of t dt, where the graph of f is shown and a is constant. So this is the graph of f. Okay. Whenever they give me this weird accumulation function, 95% of the time I'm going to need the derivative. So I'm going to go ahead and take the derivative. So g prime of x equals what? Little f of x. Okay, I'm going to use this statement because they have given me f of x to find the answers to most of these things. Okay, so let's find the relative minimum of g. If I want the relative minimum of g, I want to see when g prime changes from negative to positive. G prime equals f. They have only given me the graph of f, so I want to see where f changes from negative to positive. This is f. F is positive. Right here it changes from positive to negative. Now it's negative, 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 and then changes from negative to positive right around 5.4. I'm going to say 5.4. It could be 5.3. So where's the x value where there's a relative minimum? At x is about 5.4, there is a relative minimum. Does it ask me to justify? No. If it asked me to justify, what would my justification be? Relative minimum would be that g prime changes from negative to positive. So I'm going to say that g prime equals f, and f changes from negative to positive. Because they only gave me the graph of f, I need to reference f when I say that it changed from negative to positive, but otherwise I can't tell. Okay, so the relative maximum of g, that would occur when g prime changes from positive to negative. Where does that happen? Well, it's because g prime equals f. So when does f change positive to negative? And I'm writing the justification before I look. This is the graph of f. F changes from positive to negative right there at x equals 3. Okay, so I was looking for g prime changing signs from positive to negative, but because they gave me the information about f, I have to justify it using the graph of f. Okay, intervals where g is concave up. Okay, what am I looking for? I want G double prime to be positive. G double prime is the same as F prime. Do I have a graph of F prime? No, I have a graph of F, but F prime is the slope of F. So I want to see when the slope of F is positive. So I want to see when F is increasing. So we're going to say we want to see where F, which is the same as G prime, is increasing, which means the slope of F is positive. Okay, so let's look at the graph. Where is F increasing? F is constant, decreasing, increasing from 4 to 6. So the x values, where G is concave up, is from x equals 4 to x equals 6. So concave down is going to be the opposite. Let me mark that. So concave down is going to be where G prime is decreasing. And since G prime equals F, I want to see when F equals G prime is decreasing. Okay, so it's decreasing from x equals 2 to x equals 4. And if they don't ask for justification, I won't write that little sentence, but they sometimes do, so I'm including it. Okay, points of inflection is when this G double prime is changing signs. Again, G double prime is the same as F prime. I don't have F prime, but F prime is the slope of F. So I want to see when F changes from decreasing to increasing or vice versa. So where does that happen? Let's see, F is constant, decreasing, increasing. So right at that nice corner right here, at x equals 4, F is changing from increasing to decreasing, which I care because F is G prime. And it's changing, hold on, typo. Okay, it's changing from decreasing to increasing. Okay, last one. If G of 1 equals 8, what is the maximum value of G on the closed interval from 1 to 5? Okay, let's look at the graph. We want the maximum value of G, and this is a graph of F. F is G prime. So first, let's just consider where G has a relative maximum value on that interval from 1 to 5. So where's 1? 1 to 5 is from here to here. Where does G have a relative maximum? Well, if it has a relative maximum, G prime is changing from positive to negative, which means F is changing from positive to negative. So I'm guessing at x equals 3. There should be a relative maximum, which is also what I say. So there's a relative max at x equals 3, which is not my answer, but it's going to help me figure out my answer. Okay, so there's a relative maximum at x equals 3. So I'm going to figure out what G of 3 is equal to because they want the actual value. How am I going to figure out what G of 3 is? All they gave me was G of 1. Okay, I'm going to use an accumulation function. I know what G of 1 is. And then I want the change from 1 to 3 of G prime, which is f of t dt. So this is the value at G of 1, and this is the change that happens from 1 to 3. I can't just find the value by myself because this f represents only the change in G. It doesn't represent the actual function values. So G of 1, they told me, is 8. From 1 to 3, that's the area under the curve. So what is that? That's 2. This is 1, 2, and then this is 1/2, 1 times 2, plus 3. So then G of 3 equals 11, and I'm saying that's the maximum value on that interval because that's where the relative maximum occurs on that interval. Okay, second example is another kind of common question that comes up, and it's a little bit strange, but it's not that bad. Okay, so A, let h of x equal the integral from 0 to x over 2 plus 5 of f of t dt, where the graph of f is shown to the right. So this is the graph of f. Find the x value where h has a relative maximum. Okay, now whenever I have this weird accumulation, I assume that I'm going to need the derivative. So I'm going to go to find the derivative of h. So it's going to be h prime of x equals, the derivative and antiderivative kind of cancel each other out. So I'm going to plug in the upper boundary. But because of the chain rule, I need to times by the derivative of the inner function, which is 1/2. And then since the lower limit is a constant, I'm going to ignore that. Okay, now I can't do it exactly like the previous problem. So I'm going to at least consider the critical numbers. Okay, the critical numbers of h would be when h prime is equal to 0. H prime is f of something times half. So let's see when this is equal to 0. So f of something times half has to equal 0 when f of something equals 0. So I know that's going to happen when this is either equal to 3 or it's equal to 4.3. That inner parenthesis has to equal one or the other. Okay, so let's consider both of the options and then I'll think about which one's right. So if I do x over 2 plus 5, the critical numbers are going to occur either when that equals to 3 or when that equals to, what was the other one we said? 5.3, 5.4, somewhere right there. Okay, I want this to be a relative maximum. So I want h prime to change from positive to negative. So I'm going to pick between these two to figure out which one's going to make it change from positive to negative. So at 3, or where f is at 3, this changes from positive to negative. I times by half, it's still going to change from positive to negative. At 5.3, this changes from negative to positive. If I times by 1/2, that's still changing from negative to positive. So 5.3 is not the correct answer. So now I'm going to solve this equation for x. That's going to tell me where h prime is going to change from positive to negative. So I'm going to minus the 5, and I get x equals -4. So x equals -4 is the value where h prime, or h has a relative maximum because h prime is changing from positive to negative